Hello. My name is Stephen Hawking, physicist, cosmologist, and something of a dreamer. Although I cannot move,
and I have to speak through a computer, in my mind, I am free. Free to tour the universe and tell the ultimate story. The story of everything there ever was. From the moment the cosmos began, to the creation of our world and everything in it, and beyond, to the far, far future and the end of the universe itself. A journey through all of space and all of time.
check it out.
I spend a lot of time thinking about the universe, but I never get bored. After all, it's a pretty extraordinary place. This is the cosmos at a very large scale. Each tiny point of light is an entire galaxy, each a cluster of as many as 400 billion individual stars. This view of the universe is only possible due to the latest supercomputers. I find it indescribably beautiful. Uncountable billions of galaxies forming a vast web stretching away in all directions. What's more, I never get over the fact that within this massive universe lies one perfectly ordinary spiral galaxy. Inside that galaxy exists a commonplace yellow star, orbited by 8 planets. On one of those planets lives a species that has only just worked out what a remarkable place the universe is. Us. We've discovered more about the cosmos in the last century than in all previous human history. Finally, we are solving the basic mysteries that have perplexed our ancestors for at least 200,000 years. What I like above all is that the facts themselves are both breathtakingly elegant and surprising. We're living just as it dawns on us that the Earth and everything around us was made by the stars. Boiling furnaces of hydrogen gas, like our sun, made even the atoms in your eyelashes. We've worked out that the universe is almost unimaginably ancient, about 14 billion years old, and that it will continue to exist for at least twice that long. But without a doubt, the most remarkable fact of all is that the entire enormous universe, all the innumerable galaxies, even time and space, and the forces of nature themselves, simply materialized out of nothing. So now is a good time to be alive, I think.
We may only be an advanced breed of monkey, living on a small planet, but we are able to contemplate the universe as a whole, which makes us very special. My goal has always been simple: to work out how the universe works and why it exists at all. Luckily, there are clues everywhere, and the most important one is right above our heads.
Examine any patch of the night sky, even one as small as the head of a pin, and this is what you'll find. A tiny part of the vast web of galaxies. It's less than a millionth of what we can see of the cosmos from our little planet. But even this tiny sample is enough to find the clue, the key to the past, the present, and perhaps the future too. The clue is that seen from Earth, all these distant galaxies are slightly red in color. They appear almost as if we were looking through rose-tinted glasses. It's this very redness that reveals how the universe was born. And to show you why, I need a straight road and a noisy car. Listen to the sound as it passes by. As the car approaches, the pitch of its engine rises. As it goes away, the pitch of its engine falls. This phenomenon is called a Doppler shift, and the exact same thing happens with light. If our eyes were more sensitive to color, we could see that the car is actually very slightly blue as it approaches, and very slightly red as it goes away. The same rules apply in space. All distant galaxies are slightly red in color. So by the exact same piece of basic physics, they must all be moving away too. In fact, the whole universe is expanding in all directions, getting bigger and bigger, like a balloon inflating. I admit this sounds strange, but to cosmologists, it's like winning the lottery. Because to work out where the universe came from, all we need to do is to stop time and make it run in reverse. Rewind far enough, and everything gets closer together. A lot closer together. All the galaxies, in fact, every single thing, converges to a single point, the start of everything, 13.7 billion years ago. So it's quite simple, really. Follow the clues, and we can deduce that a very long time ago, the universe simply burst into existence. An event called the Big Bang. But I'm afraid we have to stop a moment before we get carried away by fire and noise. At the very beginning, the Big Bang actually happened in total darkness because light didn't exist yet. To see it, we'd have needed some kind of cosmic night vision. But even this, a view from the outside, is impossible. Again, it sounds strange, but space didn't exist then either. So there was no outside. The only place there was inside. This early universe was a very strange thing indeed. There's still much I'd dearly love to know about it, but standard concepts of time or space don't really apply. It was just a very tiny, ultra-hot fog of energy. Then it expanded with a tremendous flash of radiation. From smaller than an atom to about the size of an orange in less than a trillionth of a second. Almost no time at all. The universe simply inflated into existence, unfolding, unfurling, getting bigger and cooler with every passing moment. Within 100 seconds, it was as big as our solar system, trillions of miles across. While this was happening, the pure energy of the cosmos began to cool and create matter in the form of countless trillions of subatomic particles. The first stuff there ever was. Half these particles were made of matter, the same kind of stuff which makes us. The rest were made of the opposite of matter, stuff called antimatter. When the two meet, they destroy each other in a flash of energy. It seems as if building a universe is a pretty wasteful process. Fortunately, there was just a bit more matter than antimatter. Just 1 in a billion particles of stuff survived. Which was lucky for us, because that residue is what our present-day universe is made of. You could say that we are made of the smoke of the Big Bang. By the time the cosmos was 10 minutes old, it was already thousands of light years in diameter. After that, everything spread out and cooled for about 330,000 years, when finally the fog cleared and the universe became visible. So that's how everything got going, which I think is a pretty fantastic story, and probably much stranger than anything our ancestors came up with by way of an explanation. But the next thing that happened, well, that's pretty spectacular too. This is the universe seen in extreme fast forward. All 14 billion years in less than a minute. It shows how the universe changed from a cloud of gas into a place filled with perhaps 100 billion galaxies, swirling in a vast, chaotic dance. What I love to get people thinking about is that all this had to be built atom by atom. Celestial engineering on a spectacular scale. So what drove this cosmic clockwork? I'd say it was the force of gravity. The idea of gravity was worked out by Sir Isaac Newton, who had the same job as me
here at Cambridge University, back in the 17th century. It supposedly dawned on him when an apple fell on his head. The apple helped him realize that all objects attract each other. And the greater the mass, the stronger the pull. These apples are attracted to the Earth, and although you can't see it, the Earth moves very slightly up towards the apples. All things come together through the power of gravity. Gravity was created in the Big Bang and has been at work ever since. It's what keeps you, me, and apples stuck to the Earth. In the early universe, gravity had a much bigger role to play.
Right after the Big Bang, the universe was just gas, almost perfectly spread out throughout space. Over the next 200 million years, gravity began to pull the gas back together to produce the very first structures from which everything else would grow. But even this very nearly didn't happen. If it weren't for another stroke of cosmic luck, there would be no you, no me, no stars or planets or anything at all. We know this because in 1982 a group of scientists, including myself, spent 3 solid weeks working it out. Although the calculations were hard, demonstrating what we discovered is easy. First, I need a nice flat floor, like this one, for example. This is the dining room in my college. I'm going to fill the place with lots and lots of ball bearings. These balls represent the matter of the early universe, a thin gas spread out evenly across the vast cosmos. Here's where luck comes in. If they're all the same distance apart, gravity pulls each ball the same amount in all directions. They stay perfectly aligned, and precisely nothing happens. Fortunately, one of the basic rules of the universe is that nothing's perfect. Perfection simply doesn't exist. The early universe had a tiny unevenness that can be simulated by removing just 5 ball bearings. It may not look like much has changed, but to gravity, those missing balls create a giant opportunity. Gravity now pulls more strongly on one side of some of the bearings. The tiny irregularities in the sea of ball bearings have given gravity something to sink its teeth into. And this is exactly what happened back where we left the young universe. Parts of the sea of early gas were ever so slightly thinner than others. The less dense areas were like the gaps between the ball bearings. The denser parts of the sea of gas, where gravity was having its way, clumped together. And it was in these areas that all the stars and galaxies would form. The cosmos had taken its first step towards the beautiful place it is today. All thanks to irregularity, imperfection, a lack of order. So next time someone complains that you have made a mistake,
tell them that may be a good thing, because without imperfection, neither you nor I would exist.
$13.5 billion years ago, the universe was mostly hydrogen gas, with gravity doing what gravity does, which is to slowly pull it into vast clouds. Hydrogen is the simplest of gases, but it has a very special property. It's a tremendous source of power. Heat hydrogen to around 10 million degrees and it begins to produce the energy that makes the stars shine and supplies the universe with warmth and light. To see how this works, let's imagine we could make a small star here on Earth. First, we need plenty of hydrogen gas. About a sports stadium full would be perfect. Next, we need to imagine squishing this hydrogen together, just as gravity does in space. As the hydrogen compacts, the atoms of gas start bouncing off each other, and the temperature begins to rise. By the time it's compressed down to the size of a soccer ball, the hydrogen reaches the critical 10 million degrees, and a process called nuclear fusion begins. The hydrogen starts to fuse together, making a new, heavier material, helium. With every step of this tiny bump and grind, some matter gets converted into pure energy. We have created a miniature star. Of course, if this was a real experiment, you wouldn't want to go anywhere near it. The energy given off, even from a star this small, would be devastating. Back in the early universe, the same process happened for the first time on a much, much bigger scale. Gravity compressed the hydrogen gas clouds over millions of years until deep in the center, the hydrogen became hot enough for fusion to occur. The first star burst into life, pouring its energy into the vast universe. a product of the laws of nature and the raw materials left over from the Big Bang. It was almost 1,000 times bigger than our own sun and burnt a deep blue. What's more, this star soon had company. The stars were turning on. This same process still happens in our sun, which is where we get the energy we need to live. But there was still a long way to go to get from this to where we are today. You can't build a world like ours from simple gases such as hydrogen and helium. You need all sorts of other elements. You need elements like oxygen and carbon and iron and many more. But we got lucky yet again, because the very same process that causes the stars to shine also just happens to make materials like oxygen and carbon and iron. Stars, simply by accident, are giant factories. To see a star in action, let's imagine I could split one in half. Just as in the soccer ball star, the hydrogen atoms are fusing together, creating helium, which produces the star's energy. But helium is slightly heavier than hydrogen, so it sinks to the center of the star. And now the helium atoms take center stage. As they fuse together, they produce even more energy and form yet another new element: carbon. A vital building block of every living thing. The process repeats itself over and over, and the star becomes layered like an onion. A really big onion. The closer to the center, the heavier the elements, like neon, oxygen, and last of all, iron. Now things change. Iron doesn't produce energy when it fuses, so the fire begins to go out. More and more iron builds up in the star's core until almost all the remaining fuel runs out. Now gravity takes over and squashes the star in on itself. As its core gets more and more compressed, its temperature soars until it's over 100 times hotter than the core of our own sun. Finally, the star collapses and explodes. This is a supernova. The death of a star and the birth of something new. In these brief microseconds, a massive shockwave passes through the star. The blast is so powerful that it forces some of the iron to fuse into even heavier elements. And that's how heavy elements, such as gold or platinum or lead, are made, forged in the heart of an exploding star. So if you have a gold ring, make sure you appreciate it. the metal was made in a blinding flash of light billions of years ago. The finale of the process that produced the elements all around us today. It never ceases to amaze me that our bodies are constructed of the stuff of the stars,
and that our hearts beat because of the energy given off as those materials are made. But as magical as a star is, there are even more